Hello, welcome and a very nice evening to the last video in this year 2020, which was a weird year to say the least. However, I thought if I didn't do any Christmas video like last year, I'm at least gonna do a New Year's Eve video. And today we are going to code a firework effect. And of course we are going to use PowerBasic. Last year we did some falling snow effect in PowerBasic, and today we want to use this magnificent programming language from the 1990s to code a little bit of a firework. At least here in Germany it's not allowed to do any fireworks this year due to the pandemic, so let's make our own on the computer. And I'm gonna use PowerBasic because I got quite a bunch of requests to do more basic stuff. And yeah, this is a nice chance to do that. And again, this is a slightly different version of PowerBasic from last year. Last year we used the free runtime edition, or the cheaper runtime edition, which couldn't compile to a standalone exe file. This one here is PowerBasic 3.2, which I acquired in the meantime. And yeah, it actually can compile to an exe file, and it's a bit more advanced. But with slight modifications, it should be possible to use the code that I'm doing here in the runtime edition as well. So let's get started. We want to do graphics, of course. So I'm straight away going to initialize the graphics mode, which is done by the screen command, and we're using screen 7. The PowerBasic 3.2 doesn't support the 256 color modes of the VGA card. It supports the 640 by 480 16 colors, which we won't use. We will use the standard EGA 320 by 200 16 colors mode, which is screen 7 in this case. And yeah, that's what we're doing. Furthermore, at the end of the program we will have to switch back to text mode, which is screen 0 in basic terms. And then we will have some kind of loop. And this is what our run loop looks like in PowerBasic: do loop until. And instead queries the keyboard, and this is false as long as there was no key press, which is sufficient for us to do just that. In the run loop we will do the calculations and the drawing. So we'll call some subroutine, and we need to write call in PowerBasic. You can't just write the sub name as in C, where we update our particles, and we'll put something in between here. The particles will be the fireworks effect, and then we will draw the particles at some point. And yeah, there will be more stuff in between. There will be some explodey things here, but for now we'll leave it at that. Then we will also have some kind of frame counter, which will increment. This is basically the same as writing I++ in C++ or C, or I equals I plus 1, or let's say frame equals frame plus 1. We could just write that, but increment frame is maybe a bit more to the point so that you can see what it does. Also, because we want to have flicker-free animation, we are going to define two variables called active, which we'll initialize with 1, and visible, which we'll initialize with 0. These are the screen pages. EGA and VGA have multiple screen pages that we can switch around to avoid making the redraw visible. So in the back buffer, basically, in the active buffer, we will draw, and then we will show the visible buffer, which is already finished. Every loop we will swap those two variables, and that's the swap function or command. Both will be swapped around. And then we can use the screen command again, not specifying the first two parameters, which will be the screen mode and I think the color flag for CGA, but simply specifying active and visible. These are the active and visible pages, and these will swap around. Then, to make it not run too fast, we will write a VSync function. Probably we'll need to write call before that, but that's optional because this will have no parameters. So yeah, you can put either call there or leave it as it is. And then when we're in the VSync, we will also clear the graphics. This means here clear screen graphics. You can also just write clear screen, but specifying the graphics is, I think, a bit more concise. Let's have a look. And this is actually the German version, so this will not help you, but you can see you can clear the text screen or the graphics screen. Well, let's be precise and say no, we want to clear the graphics mode instead. Not sure what the difference will be, but you can try it out. I think just CLS will also work. So first of all, we need the VSync here. Also, before we write that, well, let's just start doing that. So this is actually the main program, basically. Main program. Just let's mark it as such so we can better see, because BASIC doesn't have that kind of structure, so we don't see what the main function is. These here are some kind of global variables that we need in the whole program. Globals, of course, global state, especially global mutable state, is not the best idea, but that's how BASIC rolls. So we will write some kind of subroutine VSync. And we already know that subroutine, and it in C++, in C, or let's say in C, we used that in the VGA coding. I will put up a link on the screen now. We did something like this. We would write, and I'm now translating it into BASIC, while we read from the VGA card, namely the register 3DA hex, which is the input status register. There are two flags in there which tell us if the horizontal or the vertical electron beam retrace is happening. And we're interested in the vertical retrace because during that time we can flip around the image without seeing any screen tearing. And it will also lock our frame rate to a maximum of 70 Hz on the VGA card or 60 Hz on the EGA card, I think. And that flag is actually of decimal value 8. And while this equals 1, we know we are in the retrace, so we wait until that retrace has finished. And to make sure that we are now in an active retrace, we wait while it is still not active, and after this finished, it will be just fine. This will of course be a bit costly, so we will make this sub inline so that it doesn't cost any overhead when calling it. It will just be copy and pasted by the compiler into the code below. Okay, this is the basic solution, but if we want to have it really fast, we can do better. We can comment this out, and what we can actually do is write some assembly code. And you do that in PowerBasic by just writing an exclamation mark, and then you can write any assembler code. So first of all, we will clear all the interrupts so we don't get disturbed, and don't forget to re-enable the interrupts when you're done. Clears the interrupt flag and ST restores it. Okay, so we need to load the address of the status register into DX because that's the register that you can use for the in and out commands. So we will load a hexadecimal value of 3DA. into dx, and then we will have our first loop. So we make a label, VSync1. Okay, so we read the register into the AL 8-bit register. That's doing this, read in from whatever is in dx into AL. And this gives us a status. And of course you want to see if the bit with the numerical value 8 is set. So we do an AND AL8. And we said if it's 1, we just loop. So jump if not 0 to VSync1. VSync1. That does the same as the first line. Second line, again we need to loop, so we do another label, VSync2. And we can just copy all that jazz over here. But now, instead of jump if not 0, we say jump if 0, which is the second loop. And now we have a very, very, very efficient assembler-coded basic subroutine for the VSync. Isn't that nice? So this will make all of you people happy who want to know more about x86 assembly. Granted, it's a very small routine, but I think it's pretty nice and it will work out just fine. We should also put up here some compiler flags. So because I'm running it on a 486, I'm gonna say that the CPU that we're targeting is at least a 286, which gives us more performance actually. I'm also gonna say that for size reasons, we are only including the EGA library, not the full graphics library, because we're just doing EGA graphics. This will reduce the code size a bit. For performance reason, I will turn off all error checking, especially on array bounds or stuff like that, because PowerBasic can test for out of bounds array access, etc., which is nice while developing, but when you know that your program runs fine, that's great to disable. We will optimize for speed, and we will compile for an exe file. So that's good. Also, all the variables that I don't declare are supposed to be integers. Def_int means all the variables that are labeled from A to Z. If they don't have any type, they are automatically integers. You have to know that in BASIC you make a suffix and a variable name. For example, a double variable will have a hash, an extended float variable will have 2 hashes, a string variable will be string $, or something like that, and I think integers are supposed to be % maybe, but most of the time you need integer variables, so you just say this. Actually, we will need quite a few double variables, but I want to see when I'm dealing with doubles, because they do include some performance penalties, so I'm just gonna leave them like that. So yeah, I think that's good. Let's go back to the main program. We need to implement update particles, draw particles, and we need to deal with the explosions. So we definitely need the frame counter. So we start with frame 1. And we need to have a time index because we are doing a physics simulation. So I'm going to introduce a time variable t hash or t sharp, which is a float variable or a double variable, and we'll initialize it with 0.0. Or let's say, I think it doesn't matter much. If we initialize it with 1 or 0, it doesn't matter. Also, since I want to have the rockets and the particles follow a ballistic curve with real gravity, I'm going to introduce the gravitational constant, which usually is 9.81 meters per second squared or something. But since we are scaling everything down by quite a bit, we'll reduce it to a hundredth of that size. No, a thousandth even. This is only 1,000th of the original size, which is just something that I made up because it works fine. You can tweak the parameters and see what happens with the simulation. Also, since we're doing a physics simulation, we need also an increment for the time, which I call delta t. And we will go in half steps here, 0.5 seconds or whatever that might be. I didn't try to figure out real scaling here, but just something that looks nice. Again, do play with the variables, will be nice. We also need the current number of particles that we have. I call this n equals 1, because we start with one rocket. And we need to flag if the rocket has exploded yet. Is exploded, and this will be false or 0 in the beginning. Then we need a whole bunch of state that is used for tracking all the particles. We need arrays for that, and arrays are usually done with dim in BASIC for, I don't know, dimension maybe. And you just name it as you wish. I need one array for x coordinates, I need one for y coordinates. Those are the positions of my particles. And I just arbitrarily took 256 here as a value. I'm not going to use all those actually, but you can tweak the parameters up and down to again see what looks nice, and I'm just putting in a reasonable large value here so that I don't get any overflow. Also, we will need more variables here, but we're going to stick with those for the moment until we write something of those functions. But now, the exploding part, that's the interesting thing. I figured out if the frame is divisible by 170, that is a very nice length for our formula. Just try and error how I did this here. Then we need to check if we should toggle between the rocket explodes or launching a new rocket. So every time we hit 170, 340, etc., we will check, first of all, we will reset the simulation time. So timer will go down to 0. And if the rocket already has exploded, then we're done with the exploding animation, and instead we will launch another rocket. What does it mean that another rocket launches? First of all, our rocket is not exploded anymore. We will have only one particle, the rocket, and we will call a special function called init new particles. I could also call it init new rocket or something, and it will take some stuff. We'll put that in a minute. The else path here is if the rocket has not exploded yet. That means it will explode now. So is exploded switches to 1. Again, we reset the particles, and this time we say, when the rocket explodes, we get 100 new particles, a nice shower of particles. And we will call something called init explosion, which is reasonably nice. I will also put some parameters in here in a minute. And now we will have to implement those 4 subs. Which one do we take first? Also, when the program starts, we need to call init new particles as well. And n was already initialized, yeah, because otherwise we don't have a rocket to start. Exactly. So what is the first thing that we want to do? I would say we will write the init new particles. That doesn't make sense, does it? So we write a function init new particles. And at the moment, I actually only support one rocket in theory. So we can skip the for loop, and I will just call it init new rocket. I think that's better. Init new rocket. Init new rocket. So there we are. What does a rocket need? A rocket needs some X position. We will reset the X position. It will get changed. And the rocket will be in the array at the first position. So X sharp 0 equals 0 and Y sharp 0 equals 0. I think we can even leave that out because it will be overwritten in a second in the different procedure which updates the particles, but better safe than sorry. We also need some initial position. So we will have an array x0 sharp, which takes doubles. And the X position, I figured out, is somewhere middle-ish on the screen. That means at least at X coordinate 120 plus some random value, which is R&D, minus times 80 times R&D. So this will place our rocket somewhere between pixel 120 and 200, which is a reasonable amount in the middle of the screen. Also, we will always start at the bottom line, which we will call 0 for, usually it will be row 199, but we will put that in the drawing code. So we will start at row 0. And also we need a velocity in X and Y direction. Velocity X of the rocket will be some arbitrary value, and I just figured some random value times 2, and the random values will always be between 0 and 1, so the result will be between 0 and 2. Minus 1.0, so it can go to the left or it can go to the right in every time step, more or less. And we need a vertical velocity. And there I figured something very similar, except the minimum speed will be 1 and the maximum speed will be 3 steps per iteration, which gives a pretty nice animation, in my opinion. So that is our new rocket, which will be initialized here. Also, when doing this, we should call randomize timer. This will initialize the random number generator with the current clock, and the program will render something different every time it's run. This is pretty important. Okay, what is next thing? Probably the most important thing after that is the update particles routine. So let's write that as well. And we also need to hand in the parameters actually. So we need to write something like this. In BASIC, usually all the arrays are passed as a pointer. So we just write their names here, and it will be actually pretty efficient to call the routine like that. And the one here tells BASIC what dimensions the array has. So this is a one-dimensional array. And if you had 2 or 3-dimensional matrices or something like that, you would just write how many dimensions they have, which is actually pretty nice. It's a feature that is not there in C, for example. They have to write a lot of pointer signs one after the other. So yeah, that's pretty cool. And I think that's it. We also need to define those variables. We started off here, so let's just copy that. We need the x0 and y0 and the vx0 and vy0. And I think those are all the variables we need. And of course, we need to pass those variables as well to the program when we're doing init new rocket. But this time we just leave the brackets empty, which tells BASIC, yeah, we are passing the actual array and not any value in that array. So let's copy that down here as well. I think we got all that covered. And now you can already imagine that, let's re-enable that thing, that update particles will take something very similar. But it also needs the time, and it needs to know how many particles are in those arrays actually. I think that looks good, doesn't it? So let's copy this and let's call this update particles, takes t# and n. And sub. We could also declare all those parameters as shared, so they are using the global parameters, but that's not a good style. I'm trying to do rather nice basic style here that I would also do in C or any other programming language. Because this way you can just rip out the function and use it somewhere else and don't need to introduce the globals in the same manner as in this particular program, which is a better style. Okay, so how does this work? We need a for loop, I would say. We also will take one global variable, namely the gravity constant, because it doesn't change. So that's fine. I would say this is a global universal constant, and that can be shared. Okay, we need to iterate over all the entries, so we do a for loop for y equals 0 to n minus 1. You have to write n minus 1 because in BASIC, when you start with 0, it actually goes up to n. So you would have n plus 1 entries, but we don't want to. So we need to subtract 1 from the n. And to go to the next iteration, you write next I, which is different from C++ and C. But I think we can manage. So here we will update the x coordinate of that particle. And the formula for that, you can just look it up on the internet, on Wikipedia or anything for ballistic curves, is just the initial position, x0, plus the velocity of velocity in x direction of this particle times the time step. And for the y coordinate, it looks actually pretty similar, but in the y direction, of course, the gravitational pull comes into play. And that formula says it's 1/2 times the gravitational constant times t squared. And t squared, we can just write t times t. And I think that should be it. That's our update routine. This lets us make the particles move. Isn't that nice? That's very simple. So x coordinate is just a linear movement, starting point plus velocity times t, and y is a linear movement plus the quadratic gravity term, which makes a nice ballistic curve that makes actually the typical parabola that you see when you throw a ball or anything that doesn't move with its own power. It doesn't accelerate on its own, basically. All right, that's already that. We do have init new rocket. We do have update particles. Next up is draw particles. We need to draw all the particles. And I would say it will look something very similar in the parameters to this. Do we need the time step actually? I would say no, but we probably need a color. So we take the time step away and put in the color. The color will be based on the frame, because I want to have some kind of flickery effect, twinkling basically. And we also don't need the velocity vectors. We just need the x values actually and the y values. We need to have the number of particles, and we need the frame number. But we don't take the frame number as is, but we will no, this is modulo in C and this is modulo in BASIC. We will take the frame number modulo 15 actually, because the color 0 is black on EGA and we don't want black so that it doesn't get totally black. So we add 1, so it goes from, our color goes from 1 to 15 or to 16. No, 1 to 15 actually, yes, because 15 would be 0. That should give a nice flickering glitter effect. It's a bit cheap. You can do more fancy renderings here, and if you go to 256 colors you can do color cycling instead or some other fancy stuff. But for us it's good for now, I would say. So let's copy that to our sub definition. Sub draw particles, one-dimensional arrays, and some form of color. We can't call it color because that's already taken. We can call it col, because color is a keyword in BASIC, or in PowerBasic at least. I would say we can call it col, right? So we will also do the for loop from 0 to n minus 1. We will do the next I. And we need to set the pixel, which is amazingly simple. There's a function called pixel set. And we just take the x coordinate and the y coordinate. And now comes something that I said before, because we are calculating starting at row 0, but row 0 is actually at the top of the screen and we want to start at the bottom. We need to take 199, which is the lowest column, and subtract our y coordinate from it, so we invert basically our coordinate system. And we plot it with the pixel color. So that's the particle drawing. It's just setting one pixel. That's pretty simple. So we got that covered. We got updating the particles, drawing the particles, initializing a new rocket. Now we need to initialize the explosion. How do we do that? And that's actually pretty similar to initializing a rocket, except that we need to know how many particles to initialize. So basically there's another parameter n here. More like this. So we can take this whole stuff here and create another sub. And again, we need to specify the dimensions. All the arrays are one-dimensional in this case. And sub. And I would say this time we need to know where to start. So we call this the x1 position. And that's actually the position of the rocket. And we put the position of the rocket in the 0th position of the array. We need to store that because we will overwrite that value because the rocket ceases to exist. That should be y0. So now we have the position of the rocket. And now we can initialize all the particles for I equals 0 to n minus 1 and 4. We can do some stuff. What is the stuff? So basically I want to create random points around a circle n random points around the circle with a random angle and with a random velocity. So I need to create two random values. The random velocity I call v0, and that will be 1.5 times some arbitrary random value between 0 and 1 plus 0.5. So the slowest particle will be 0.5, the fastest particle will be speed 2. And we need an angle. I call this angle theta. Theta will go from 0 to 2 pi, because that is one time around the circle. And one time around the circle is 6.28318 roughly. You can use a better approximation. And we say times R&D, so we get something between 0 and 2 pi. That's nice, isn't it? But we need to convert that to proper coordinates, right? Especially to x0, y0, and velocity coordinates. So x0 and y0 are very simple, because those are actually just x1, the position of the rocket. That's our initial position for every particle. They start in the center of the rocket and then they stream outward. So let's just do that. Actually, we need to use the subscript here because it's an array. So every particle will be initialized to the same position where the rocket was. And then, of course, the velocity of this particle. And that's always the same. And we could actually, no, we could not. This is fine. This is different for every particle. We calculate it for every particle new. So velocity that we just gambled times the cosine of the theta and the y-coordinate. And you can look that up why that is the case. That's basic trigonometry, you know, angles and circles and stuff. So velocity in y direction is the sine. If you take a look at how a right triangle is defined, you will see that this is the case. And that's it. Every particle now has a random direction and a random velocity. And they will spread outward at different rates, and hopefully it will look nice. Do we have everything? What did we put in here? We put a lot of compiler flags in here, which is fine. They don't do anything. We learned how to program a little bit of assembly language in BASIC. We put in a new rocket whenever we need, and I hope this is all right. We have a simple formula to update the particles, which is the ballistic curve formula that you can also look up. We have the draw particles, which is very simple. It's just setting pixels. We have the init explosion, which was a bit complicated, but also not too much. Particles start at the position of the rocket, and then they stream randomly outwards in a circle. We have a bunch of more or less global variables in the main function. We are creating one rocket and then enter the main program, basically. Going to graphics mode, updating all the particles, drawing all the particles. Then every 170 frames we are either creating a new rocket or exploding the current rocket. Counting up the frame. And we forgot one thing. One thing that we forgot is we did not have an else here because we need to increase T#. Otherwise the simulation won't work. So if we're not at frame 170 or a multiple thereof, we just need to continue the simulation. Bam. So that's that. Let's see if that compiles. There's a next expected. N4 I wrote. That's of course not right. Okay, that's it. Shall we try to run it? And nothing's happening, which is not the best thing. Let me quickly debug that and I'll get back to you. And one of the problems was that I was missing the hash at the end, so it was supposed that theta is an integer variable which was initialized with 0, which is of course a bad thing. And a similar thing happened to me further up, I think. I think with the init new rocket there was something missing here, something was wrong here with the variables. If you scroll back a bit in the video, you will probably notice it. This is the drawback of BASIC, where you don't have to define any of your variables. When you reference a variable that hasn't been defined, it's just assumed to be 0, which is good for beginners but bad for all the larger projects. It's nicer if you have to declare all the variables, because then you know, okay, those are the things that I actually want to use. So, without further ado, let's run it. And there goes our rocket, and boom, it explodes. And as you can see, it works fine. It looks probably a bit weird, but I think it's a pretty convincing simulation, and one which uses very few lines of codes actually to produce such a thing. I think the coloring could be a little bit different, but I think the shimmer is actually not that bad. It's cycling very quickly through all the colors, which makes some kind of glittering effect. You can try to do some other stuff, use solid colors or whatever you want. Yeah, but I think this is a very nice effect, and I hope you learned something here. Please consider subscribing as usual. I want to thank all of the subscribers. We are closing in on the 2000 mark, past the 1800 now. And I'm very grateful for everyone who stayed around, especially through this weird and hard year. And I hope you all at home are healthy and are not too affected by the pandemic. I mean, everybody is, and maybe there's light at the end of the tunnel. Vaccinations are coming out. I hope they work. I hope people get healthier and better, and we can return to a bit of a more normal life in 2021. As I said, subscribe, share, like, comment, put in your comments onto this code or whatever you want to discuss regarding BASIC. You can also support me as usual if you want, or maybe at the end of the year you want to donate to some other cause, which is also fine. Links are down in the video description as usual. All I can say is have a very good new year, have a very nice 2021. Thank you for sticking around, and I hope to see you soon in the next videos, be it Let's Code or some other tinkering. So until then, bye.